Yeah, the first challenge was it was infant porn, right? So it was a very easy task. So I just performed the buffer overflow attack. So if you want, we can just try to go and check the source code, right? Okay. So it was this challenge. So it was a very easy challenge. So what all you need to do is that you need to enter the edge amount of data in it. So the buffer will get filled up, and at this certain point it will gonna crash. So it will gonna override the instruction point and break into the next function. So we have got successful login, right? So if we connect to the CTF server, so we'll gonna get a flag. So if I go to the next challenge, so it was a good one. Actually, I tried to do as much as I can, but I didn't, right? So I can just show you all the code over here. So this one was, I guess, was it of challenge, right? Yeah. So it was of mm, it was of to call that secret function, right? So what I did was that, so it was a very easy task to show you all. It was a very easy task. So let me go to that directory. So this binary was provided to us, right? So we need to enter your name. So if we enter our name, so we need to first check the buffer overflow, right? So if we hit enter, so we see that address point error. So while solving any kind of CTFs, we need to first do some check seg over here. Check seg and the name of the file. So in this case it was child2, right? So as we can see, it has none of the security measures run, right? So we can perform anything over here. Anyone including buffer overflow, right? So I'll just gonna show you the code. So basically it is a 32-bit architecture file. So I've set it to context.library to the same elf file. Then I'm trying to start the process, and then I've just got the return address functions address and the flag address functions address, right? And then I first found out the cyclic pattern using pawn debug. It is a great tool for beginners. And then after the particular offset, we are just trying to write the return address, okay? And from there we are trying to jumping on the flag address. So for debugging purpose, I've just written the payload into the buff.txt. You know, if the payload or exploit doesn't work, we can manually debug it using bond debug tools and all. And then I'm trying to receive until the name, and we are trying to send it buffer and making it interactive if the shell is possible, right? So it is a good practice to at io.interactive. So let's run this exploit. So before running this exploit, we need to first create the flag.txt file over here, because or else it will throw us an error. So if I just try to say python exploit.py, and we got the fake flag, right? So in this way we got the second one. And the third one was like Hall of Fame part 1, right? So it was like a very challenging task to me, but yesterday at night the admin WhatsApp me and told me that it was a very easy task, but not so that we should leak the canary value, right? So I got to learn something new from that. So let me go to that challenge. So it was this particular one, right? So first it is trying to set up the canary value over here, and it is trying to match if the canary value is actual or not. If not, then we are trying to leak it, right? So basically we want to leak the value of actually local 10. So we can just try to rename this variable canary right? So from there we are just trying to then call the that set a banner of that CYCTF, and then we are trying to read the buffer of 20. So due to limitations we cannot try to do some buffer overflow attacks, because the canary value is enabled. So from there, if you see on the next line, there is printf, right? So if you all don't know about format string vulnerability, so I'll just give a bit idea. So it tries to leak the addresses from this track, right? So if I enter percent bit, so it will not going to print at percent bit, so it will going to print the pointer or the address of the stack in that particular address in the form of output, right? So using that, I first linked all the addresses from this stack, and when I try to link all the addresses from this stack, I've gotten the canary value over there. Okay, so canary value, if you all want to know about it, so if I just try to run this exploit.py file, oops, I'm not in the same directory, I guess. It was in 02, no? Okay, so I've created a two files actually over here. The first file was to get the canary values, means to link all the data from the stack, and the second file was to basically do the all the exploration part, right? So if I just try to run the UITH Python exploit.py, so if you see, I've clicked the first 50 values from the stack, right? So now the main point to identify canary is that at the ending of the address, it will gonna have two zeros, right? So because canary is a full brand new value in the stack with the ending of double zeros, so if we see, there are many of those, like at the point 13 there is one more canary over here, and if we try to see at the time of 26th value, there is one more canary over here, and the address I guess at 33. So basically there are three addresses. So we need to do some trial and error. So for the basic, I took the canary value of this at the first time. Okay. So then I'll just show you the code. So here you can see I've set it up the basic spawn tool utility, and canary values 13, 25, 33. So first I've taken 13. So at the 13th address, so it will gonna send, right, and then we're gonna get the value of the canary. So I've done some splitting method because there was a large output and all, and I've cut it and got the exact canary value, and from there I've matched the canary value, and after the canary value I've inserted the malicious buffer, and the other thing is totally same, like return to secret function, right, from the challenge part 2. So if I just try to run this python 3 new.py, you can see we got the fake flag. So canary value in hex is this one, canary value in the integer is this, and sending the malicious buffer, and in the same way we got it.